So we're going to briefly recap the concept of completing the square. So let's start by looking at an example of an expression that could be described as a perfect square, x squared plus 6x plus 9. This is a perfect square because we can factorise it as x plus 3 squared. Now, the vast number of quadratic expressions are not perfect squares. So, for example, x squared plus 8x plus 1. We can't factorise it as a perfect square in the same way, which is where this process of completing the square comes into play. So what does completing the square actually mean? Well, it means that we take a quadratic expression and we rewrite it in the form x plus p all squared plus q, where p and q are numbers which could be positive or negative. Let's start with the example from above, x squared plus 8x plus 1. So I'm going to rewrite it as x plus 4 all squared, which gives me part of the result. Now, I know it's going to be x plus 4 all squared because if I expand that, x plus 4 multiplied by x plus 4, this will give me x squared plus 8x plus 16. And crucially, this will give me the x squared and the 8x that I want here. Now, I need to adjust this, so I'm going to subtract the 16 that I don't really want here, and I'm going to make sure I add on the 1 that I do want. So this gives me my expression in completed square form, x plus 4 all squared minus 15. Let's try another example. So we're going to look at x squared plus 4x subtract 10. So again, it's going to be x plus 2 this time all squared, and you can expand those brackets. X plus 2 all squared is x squared plus 4x plus 4. So you have the x squared and the 4x that you want over here. Now we need to get rid of the minus, we need to get rid of the 4 here, so subtract 4, and we need to make sure we include a negative 10. So our result will simplify to x plus 2 all squared minus 14. So here are our final answers in their completed square forms. It's worth reminding ourselves that the number inside the brackets here, and for example here, is half of this value here. And of course the reason for that can be seen when you expand the square bracket here. Let's have a look at one last example here, which is x squared minus, this time, 10x minus 4. So this is going to be x minus 5 all squared. And then at the end of this, we want to make sure we subtract the 25 and subtract 4. This will give us a final answer of x minus 5 all squared minus 29. So let's have a look at a slightly harder example. So the example that we're going to look at is x squared plus 3x plus 7. Now, when we start writing it in its completed square format, we're going to have x here, and then we're going to have plus 3 over 2, which of course is half of the 3 here. Now, that needs to be squared. When this bracket is expanded, it's going to have a 3 over 2, which will be squared as part of the expansion. So I want to remove that. So I'm going to remove my 3 over 2 squared part. And of course, I want to make sure I add on the 7 at the end here. So let's simplify this. So this gives us x plus 3 over 2 all squared plus 19 over 4. Now you can work that out with a calculator, or if you work it out without a calculator, you're doing the calculation 7 subtract 9 over 4, which is 28 over 4, subtract 9 over 4, and then from there you can clearly see the answer is 19 over 4. Now let's look at some different examples where we've got to be able to complete the square, which are a little bit more complex. You'll notice straight away that we no longer have a coefficient of 1 with the x squared, we have a coefficient of 2, so it's 2x squared rather than just being x squared. Now our aim, if we're completing the square with this, is to express it in the form p x plus q all squared plus r, where p, q and r are numerical values. Now, this is one way in which we can do this. I'm going to factorise just the 2 out of only the first 2 terms. So 2 bracket x squared plus 4x. We're not used to doing factorisation like this. We're used to factorising out the x as well, but I'm just deliberately taking the 2 out of these 2 terms. And of course, at the end, there is a plus 1, which I will leave there. I'm now going to start with this part here, underline it in green so you can see that, and I'm going to complete the square using these 2 terms. So in the bracket we would have x plus, and it would be a half of the value in front of x here, in fact half of the coefficient of x, which is 2, so that's x plus 2 all squared. Now, think about what's going to happen when you expand these brackets. You've got 2 bracket x plus 2 all squared. So that's 2 lots of x plus 2 multiplied by x plus 2. So this 2 is going to be squared, but it's also going to be multiplied by this 2 over here. So we'll have 2 multiplied by 2 multiplied by 2 when the expansion is done, which will give us an overall result of 8. We're going to remove that 8 and then we're going to add the 1 from up here at the end. All that remains to be done is to now simplify this, so we have 2 bracket x plus 2 all squared minus 7, and we are done. So we can see our p value is equal to 2, our q value is equal to 2, and our r value is equal to negative 7. Let's see if we can do this again with another example. So I have 3x squared minus 12x minus 5. Same first step. I'm going to factorise, this time the 3, out of the first 2 terms. So let me take out 3. In my brackets, I then have x squared minus 4x. And this minus 5 is just replicated at the end here. Now, let's take the x squared minus 4x and we'll write it as x minus 2 all squared, nearly. Of course, there is some adjustment to be done. So again, you want to think about what will happen when you expand this pair of brackets, x minus 2, and multiply by 3. You've got a 3 here, which is going to multiply this negative 2, which is also going to multiply this negative 2 here as well. So that, of course, is going to give us an answer of positive 12. So we want to remove that positive 12 and then include this negative 5 at the end. And the last step is then just simplifying everything we have, which gives us this as our final answer. Let's look at another example, which is slightly trickier. 2x squared minus 6x minus 1. Same first step. Let's take the 2 out of these first 2 terms. So we have x squared minus 3x. This negative 1 will just be included at the end, like so. Now, of course, when we then start to look at completing the square, we have a 3 here in the bracket, so it's going to be x minus 3 over 2, or minus 1.5. It's better if we can work in fractions, though, a little bit neater, squared. Now, let's go from here. So we need to know what happens when we expand these brackets. So we would have 2x minus 3 over 2 multiplied by x minus 3 over 2 when we multiply out this square bracket here. So that's going to give us a 2 multiplied by a negative 3 over 2 multiplied by another negative 3 over 2, and that of course will give us a value of 9 over 2. So I want to subtract 9 over 2 and then subtract the 1 which was originally there. This then simplifies to give me 2 bracket x minus 3 over 2 all squared minus 11 over 2. Let's do one last example of this. We have negative x squared minus 4x plus 3. So I'm going to take out a negative 1, which can just be written as a negative sign, outside of x squared plus 4x. Think about it. If you're taking out a negative 1, when we expand back, we want to be able to produce negative x squared and negative 4x, so it has to be a plus 4x here in the bracket. There is, of course, a plus 3 at the end there. Now, let's take these first two terms here, x squared and 4x, and let's rewrite that as x plus 2 all squared. Now, let's see what happens if we expand the negative of x plus 2 all squared. This is negative x squared plus 4x plus 4, which simplifies to negative x squared minus 4x minus 4. Now, the negative x squared and the negative 4x are clearly what we want here. We need to make sure we remove this negative 4. So I'm going to add 4. And at the end, I'm going to subtract 3. This then gives me my final answer, negative x plus 2 all squared plus 1, which if we want to, we can write as 1 subtract x plus 2 all squared. And a little bit later on, we'll be talking about the significance of expressions like this, where there is a negative x squared term. So let's now look at how we can solve equations using completing the square as a strategy. So we're going to have a look at a couple of examples. We'll start with this one, x squared plus 4x minus 3 equals 0. I'm going to start off by completing the square. Notice this is now an equation rather than an expression, and you can see the equals 0 here, meaning that this is an equation, not just an expression. So completing the square, we want x plus 2 all squared. Now this will then give us a 4 when we expand the bracket, so I'm going to subtract the 4. That will be the result of this 2 being squared, and then I want a minus 3 at the end equals 0. Let's simplify the left-hand side. X plus 2 all squared minus 7 equals 0. And now, avoid the temptation to expand the brackets. If you do that and then simplify, all that will happen is that you will go back to the beginning. That's not what we want to do. We want to add 7 to both sides here. So we get x plus 2 all squared equals 7. Now, square root. So x plus 2 equals plus or minus. Remember, quadratic equations, we need to seek the two roots. So plus or minus. And x then equals negative 2 plus or minus root 7, the last step being the subtraction of the 2. And we have our two roots to our quadratic equation in surd form. Let's have a look at another example and see if we can do the same thing. X squared minus 10x plus 7 equals 0. So I have x minus 5 all squared. Now when I square the negative 5, I'll get a positive 25, which I want to remove. And then over here I can see I have a plus 7 that I want to include, all of which equals 0. X minus 5 all squared minus 18 equals 0. And then let's add the 18, so we have x minus 5 all squared equals 18. Take a square root, so x minus 5 equals plus or minus root 18, and then add the 5, so x is equal to 5 plus or minus root 18. Now we can go a little bit further here because root 18 simplifies further, so root 18, I want to break it down into root 9 root 2. Which means I have 5 plus or minus 3 root 2, when I'm working in a fully simplified surd format. Now we're going to have a look at one last example. Solve 2x squared minus 12x minus 9 equals 0. So we have a quadratic equation with a 2x squared term. So remember how we completed the square? We took the first two terms and we will factorise 2 out of there because that's the coefficient or the multiplier of x squared. X squared minus 6x in brackets. Remember, it's not a full factorisation, we're just taking 2 out. And then this minus 9 is written at the end like so. This gives us 2, and then in brackets, x minus 3 all squared. Now, when we square minus 3, when we expand the brackets, that will give us a 9. This 9 is being multiplied by the 2, which will give us an 18. So we want to remove that 18, and then we also want to make sure we include what's already there, which is a negative 9. So this then gives me 2 bracket x minus 3 all squared minus 27 equals 0. Now, let's start solving. I'm going to add 27 to both sides. So I get 2 bracket x minus 3 squared equals 27. Do not square root as the next step. You need to divide by 2 first of all. So x minus 3 all squared equals 27 over 2. Now let's square root. X minus 3 equals plus or minus root 27 over 2. And then add the 3, which gives us x equals 3 plus or minus the root of 27 over 2. Now we can do a little bit of simplification here because root 27 over 2 will simplify to root 27 over root 2, which is root 3 multiplied by root 9 over root 2, or 3 root 3 over root 2, and then as a final step we can rationalise the denominator multiplying by root 2 and root 2 here in the numerator and denominator, which gives us 3 root 6 over 2. So our final answer for x, or our roots, can be expressed as 3 plus or minus 3 root 6 over 2. And we are done. Now the last thing that we're going to do is apply completing the square when we want to find the coordinates of the turning point, the maximum or minimum of a quadratic function. Let's start straight with an example. Y equals x squared plus 6x plus 8. Now this is now a quadratic function and we've introduced y as well as x, which means we're linking x and y coordinates, so this represents a graph, and you know that quadratic graphs will take this shape, sometimes this shape, depending on the coefficient of x squared. And we can identify the coordinates of the minimum point or the maximum point, also called the turning point in general, by completing the square. So here's how we will do this and how we will set out our work. I'm going to complete the square underneath, so I have x plus 3, which is half of the 6 there, remember, all squared. Now when I square my brackets, I will get a plus 9 at the end of that, so let's remove that 9 and let's make sure we include this 8 at the end. So this gives me y equals x plus 3 all squared minus 1. Now, how do I find my coordinates of the turning point, which in this case is a minimum point? Well, I think about the fact that this part of the graph's equation, this part of the function, is a square. Now, squares must be greater than or equal to 0. Okay, think about it. You can't square a number and get a negative value, certainly not at this part of your understanding of mathematics. So squares must be greater than or equal to 0. Think about square numbers. 0 times 0 or 0 squared is 0, 1 squared is 1, etc. You go up through the positive numbers. So squares must be greater than or equal to 0. So the minimum value of x plus 3 all squared is 0. Now, if this part here is equal to 0, this would then give us y equals negative 1. So the minimum possible value of y is negative 1, which occurs when x plus 3 all squared equals 0. Now, if x plus 3 all squared equals 0, that means x plus 3 must equal 0, which means x equals negative 3. So the coordinates of the minimum point, and we know that this particular parabola has a shape like this, with a minimum point, because it has a positive x squared term. The coordinates of this minimum point are negative 3, negative 1. Let's try another example. Y equals x squared minus 8x minus 15. Again, this is a positive x squared graph, so it will have a shape like this. Let's complete the square. X minus 4 all squared. Now when we square out these brackets, x minus 4 all squared, we will get x squared minus 8x, and we know we're going to get a plus 16, so let's remove that, and then let's just include the positive 15 that should be there, that was there at the beginning. So this gives me x minus 4 all squared minus 1. Now again, I want to find the coordinates of this minimum point here. So let's look at this portion of the graph. Now, the minimum possible value of a square is 0. So x minus 4 all squared equals 0, and that's the minimum value that the square can take. Now, if this red part is equal to 0, this then gives us y equals 0, take away 1, or negative 1. So the minimum possible value of y is negative 1. Now, how do we achieve that? Well, x minus 4 all squared must equal 0, which means x minus 4 must equal 0, which means x must equal 4. So the minimum point of this quadratic function takes coordinates 4 for the x coordinate, and negative 1 for the y coordinate. Let's try a more complex example with a 4x squared at the start. Now again, because it's a positive x squared term, 4x squared, it will have another minimum value like this. The graph will take this shape here. Now let's complete the square. So we're going to factorise out this 4 from the first two terms. That's 4 bracket x squared minus 4x. And then the 15 is just here at the end. Remember, we haven't started completing the square just yet. All we've done is factorise out that 4. So that's 4 lots of x minus 2 all squared. Now, let's think about what happens when we expand this part here. We're going to end up with 4 multiplied by negative 2 multiplied by negative 2 as part of the expansion, which will give us 16, positive 16. So that means I need to remove that 16 and I need to add on that 15, which was already in existence. So my completed square is 4 bracket x minus 2 all squared minus 1. Now let's work out the minimum value. I'm going to focus on this portion over here. Now it's really the part in brackets that I'm interested in because we've got 4 times a square number. Now remember, a square number can take as its lowest possible value 0, and multiplying by 4 doesn't really make any difference. The 4 is always there in the answer. So it's 4 times a square. So we know that the minimum possible value of a square is equal to 0. So the lowest possible value of x minus 2 all squared is 0, and multiplying by 4, as I said, does not affect this, because if x minus 2 all squared equals 0, multiplying that by 4 will still give us 0. So the red contents, or the contents of the red box, will always still be 0 when x minus 2 all squared is 0. So this would then give us y equals 0, which is the contents of the red box, take away 1, y equals negative 1. Now, when the red box equals 0, x minus 2 all squared equals 0, which means x minus 2 equals 0, which means x equals 2. So the coordinates of my minimum point are going to be 2 for the x-coordinate, negative 1 for the y-coordinate. Now let's summarise the results that we have so far. For the first example, in completed square format we have this, and the minimum point is this. So notice that the x-coordinate of the minimum point is negative 3. It's the value that makes the bracket equal to 0. If x equals negative 3, we have negative 3 plus 3, which gives us 0. The same in the second example, the x-coordinate of the minimum point is 4. 4 take away 4 gives us 0. And the same in the last example as well. Regardless of this 4 multiplying factor at the front, if x equals 2, we have 2 minus 2 in the bracket, which squares to give us another 0. Now, some people like to remember that if you take the opposite of what you have in the bracket, you get the x-coordinate of the minimum point, because of course it's the reverse of that value that will cause the bracket to equal 0. Now, the y-coordinate of the minimum point is then always going to be the value here, because of course when the contents of the bracket square to give you 0, you're left with the y value of 0, take away 1 in this instance. Now, it's a bit of a coincidence that the y-coordinate of the minimum point was negative 1 in each of these examples. It won't always be negative 1. For instance, if we have y equals x squared plus 4x plus 14 as a different example, I'll complete the square, which is y equals x plus 2 all squared plus 10. Can you work out what the coordinates of the minimum point are going to be? What x value will make the bracket 0? It's an x value of negative 2, which you might like to think of as the reverse of the positive 2 that's in the bracket. Now, if the bracket equals 0, 0 squared is then 0, y will then be equal to 10. So the minimum point has coordinates negative 2, 10. Now we're going to finish by looking at one last example, which we briefly mentioned earlier on. Y equals negative x squared minus 2x plus 5. Now, the fact that this features a negative x squared means that the shape of the graph looks like this, which means it doesn't have a minimum as its turning point, it has a maximum as its turning point. Let's complete the square. Like we did previously, I'm going to take negative outside of the first two terms, which gives me x squared plus 2x, and then there's a plus 5 left over at the end. Let's start completing the square, so that's negative x plus 1 all squared. Now, when I expand these brackets, negative x plus 1, x plus 1, let's actually do the full expansion. So x squared plus 2x plus 1, which will give me negative x squared minus 2x minus 1. So we end up with this minus 1. Now I will need to get rid of that minus 1. So I need to add 1 to remove it, or minus 1, which is the same as adding 1. And then I want a plus 5 at the end. So this simplifies to negative x plus 1 all squared plus 6, which I like to rewrite as 6 take away x plus 1 all squared. Now, think about what we're trying to do. We're trying to maximise the value of y. Now, y is equal to 6 take away something. So, because x plus 1 all squared will always be 0 or above, the lowest possible value you can make the red box is 0, which will give y its maximum value of 6 take away 0, which is 6. Okay? So when does the red box become 0? When x plus 1 all squared becomes 0, which means x plus 1 must equal 0, which means x must equal negative 1. Think about it. When x is equal to negative 1, if you substitute that in, the bracket becomes 0. You then square this, which is still 0, so you're doing 6 take away 0, which gives you the maximum possible value of y. Otherwise, you're always going to be doing 6 take away something, which will give you an answer smaller than 6, because the red box can never be negative because it's a square, and squares are always 0 or above. So this then gives us our maximum point, which has coordinates -1 as its x-coordinate and 6 as its y-coordinate, which can be seen in the same way. You're reversing what you have here for the x-coordinate, and then your y-coordinate is simply part of the equation like this.